We want to continue to look at trig equations today. And let's start off by looking at where we previously were with our trig equations. So we have two examples here. The sine of x is square root of 3 over 2, and we're on 0 to 360. So in our unit circle, we're looking at where is our y coordinate, square root of 3 over 2, and we have 60 and 120. So we get 60 and 120. And if we wanted to do radians and we looked at cosine as negative 1/2, we would go and say, where is the x coordinate? Negative 1/2, and we get 2 pi over 3 and 4 pi over 3. So that's what we've looked at previously. Now, what we want to look at today is what happens if what's inside our trig function here is not just x. Let's say we have sine of 3x equals square root of 3 over 2. Now, the first thing we're going to do is we're going to just ignore the 3 for a second, and let's just pretend this is x. So where is sine of x equal to square root of 3 over 2? And that's our first problem that we solved. We had 60 and 120. So let's write down our 60 and our 120. And then talk about how we can use those to solve sine of 3x. Now first, let's go look at this sine of 3x, and let's think about graphing that. So let's go back to what we know about graphing. We would find our period. That 3 changes our period. This is 2 pi over 3. So sine starts at 0. It would end at 2 pi over 3. In the middle, it's at 0. In the middle here, it's at 1. In the middle here, it's at negative 1. Our 5 key points. And we would sketch our graph. Now, that's one period, but we're solving these questions on 0 to 2 pi or 0 to 360. So let me kind of just doctor this a little bit and change it up so this graph repeats over and over again so that it goes all the way to 2 pi. So you can see what happens here when you put that 3x in the same distance from 0 to 2 pi. I now have 3 sine curves. So it changes. Let me change the color here. You can see I have the red, the blue, and the red. I have 3 separate sine curves. So what's going to happen is where I try to find where is that equal to square root of 3 over 2, which is about 0.87, which is right about there, you're going to notice that I am not going to get 2 answers like before when we were on the unit circle. I'm actually going to get 6 answers. 2 that we normally get times that 3. So how can we find these 6 answers? So that's what we want to talk about here today. Now, we're not going to need to graph. We're not going to need to use this at all. Let's go back to look at our problem. And here's what we're going to do. So we found our first 2 answers. Now, with what we looked at previously, we are then going to say our plus or minus 360n. And really, we only really need the plus here because we're solving these on 0 to 360. We're really only looking at the positive answers for today. But this is going to be equal to 3x. Now what we're going to do is we're trying to solve for x. So what I'm going to do is I'm going to divide by 3. And if I divide by 3, I will get x equals 20 plus 120. N. I forgot my n here, I am sorry. And if I divide by 3 here, I get x equals 40 plus 120n. Now, I'm going to start here. and I'm going to start at 0, and I put 0 in. So this is 120, or 20 plus 120 times 0, which is just 20. And I plug 0 in down to here, and that gives me 40. There's my first answer. Then I go n is 1. So if I put 1 in for n, I have 20 plus 120, which is 140. If I plug n down here, I have 40 plus 120 is 160. Then I put n is 2 in. So 120 times 2 is 240. So this would give me 260. And then 240 plus 40 is 280. Now, a couple things here you can think about as we get to this point. One, the number here was 3. So since that's 3, I have 0, 1, 2. That's my 3 answers. For each of these values, 60 and 120, I am going to get 3 answers for. But another way to notice is if you tried to put 3 in, you would get 20 plus 3 times 120, which would be 360, which would give you 380, which is bigger than our 360. So what you start is you plug in 0, 1, 2. You just keep going until you get an answer bigger than 360, and then you know you have to stop. Here are our 3 answers. So here are our 6 answers that we would have got. And as we went back to here, we realized we got those 6. But we don't need to look at that graph to be able to actually solve these. Okay, let's look at another one. Cosine of 2x equals negative square root of 2 over 2. So the first thing we want to do is we want to find where is cosine equal to negative square root of 2 over 2. And that is 135 and 225. So we're just doing this like before, finding our 2 answers on the unit circle. But this is equal to 2x. We're going to add our 360 in. And remember, we're only dealing with the positive one here, unlike what we looked at in the last section, because we're only on 0 to 360. Now we're going to divide everything by 2. So 135 divided by 2 is 67.5. And 360 divided by 2 is 180. 225 divided by 2 is 112.5. And then 360 divided by 2 is 180. So we start when n is 0, and we will get 65. So 0 times 180. And then those. Then we go to n is 1. So if we put 1 in here, we have 180 plus 67.5, which is 247.5. And then 180 plus 112.5 is 292.5. So there is our 4 answers. As we said before, you can see if we went to 2, 180 times 2 is 360. We'd get an answer over 360, so we know where to stop. We also know to stop. We always start at 0, 0, and 1, because we have a 2 here. So one more. Sine of 2x is negative 1/2. So if we think of where sine is negative 1/2 on our unit circle, negative 1/2 is 210 and 330. So we have 210 and 330. Those are our just straight on the unit circle. Now we have 2x plus 360n we divide by 2. So everything gets divided by 2. So we get x equals 210 divided by 2 is 105 plus 180n. 330 divided by 2 is 165 plus 180n. So we start when n is 0, and we get 105 and 165. Then we go to n is 1, and we have 180 plus 105 is 285. And 180 plus 165 is 345. And there are our 4 answers. 1, 2, values of n, because we have a 2x. All right, you are now ready to do trig equations homework number 3.